Okay, let's take a look at this question, which is about bond energies. Okay, so firstly, the equation for the reaction of ethene and bromine is, and it gives you the equation below, tells you some interesting other stuff as well, like the different phases they're in and so on. All right, and then it tells us that the reaction is exothermic, which immediately gives us some important information that's required to finish the question. Complete the energy level diagram. This is pretty standard. Most exams will ask you to do this. But then you've got to make sure you continue reading, and it says you should label the activation energy and the enthalpy change. People do miss these things off. If there's a bullet point in the question, make sure that you answer the bullet point in your answer. So if it's exothermic, then if that's the reactants, we know that the energy in the products must be less. So the exothermic shape is up, down, and then your final line should finish below the level that your reactant started at. And then you have to do the labeling. Activation energy goes from the energy level of the reactants up to the top of the curve, and make sure you label it because that's what it asks you to do. Also then, the enthalpy change, that's the energy in the bonds in the reactants, that's the energy in the bonds in the products. Your enthalpy change is that difference there. Okay? Make sure you draw it on and make sure you label it. Now, pretty standard as well, the next part of the question asks you to actually work out those bond changes numerically. So I'll just give you a few seconds to look at that table. Okay, so there's the equation, but this time it's shown in a structural fashion, so you can see how many bonds of each type there are. And I've written these numbers here. So that's the reactants, that's the products. And you work out how many bonds are on each side of the equation in total. So on the reactant side, we've got 4 carbon-hydrogen bonds. 1, 2, 3, 4. That's that number there. We've also got 1 carbon-carbon double bond. 1. And we've got 1 bromine-bromine bond. There you are. And all those energies there are the energy for one single bond of that type. On the product side, we've got 1 carbon-carbon bond. We've got 2 carbon-bromine bonds. 1, 2. And we've got, again, 4 carbon-hydrogen bonds. There we are. So we've listed all the bonds and we know how many bonds of each type there are. And there's your question. Pretty standard. Calculate the enthalpy change. That's the symbol for the enthalpy change, the energy change for the reaction. So that is a list of the bonds that are in the reactants. There's your 4 carbon-hydrogen, your 1 carbon-carbon double, and your 1 bromine-bromine single. Now, if you times out the energies for them, 4 times the energy for a carbon-hydrogen bond gives you 1652, and for the rest it's just one bond. So you've got your 614, your 193. You add those up, you get 2459. That are the bonds in the products. 4 times carbon-hydrogen again, so it's the same number, 1652. And you've got 1 carbon-carbon bond, which gives you 348, and 2 times carbon-bromine bonds, which gives you 552 altogether. Add those up and you've got the total energy in the bonds of the products. That's 2552. Now, let's make sure we get this the right way round. You always subtract the products from the reactants. So the energy we've worked out for 1 mole of the reactants bonds is 2459. The energy in the products bonds, 2552. So your sum there will be 2459 minus 2552. Okay? Now that gives you an answer of minus 93. That's very important, right? That minus tells us that yes, this is indeed an exothermic reaction. If your sign is negative, it's exothermic. If it's a positive number, it's endothermic. Make sure you write that in the correct place. Minus 93 kilojoules per mole. Now the final question asks you to explain why this happens in a descriptive way, not numerical, and this is the bit that people find a bit harder. But the answer is pretty standard, depending whether you're explaining if it's exothermic or endothermic. This one, the reaction is exothermic. Explain why in terms of bonds broken and bonds formed. So you have to do what the question says. It wants an explanation, but it wants you to do it in terms of bonds broken and bonds formed. They're the important words. And this is why. More energy is released when the new bonds are formed than was required to break the bonds in the reactants. So that means that there is an excess of energy. And where does that energy go? Into the environment, which is why the reaction is exothermic. Okay, hope that helped. Speak to you soon.